Let's look at a fairly simple approach to natural language processing called bag of words. So imagine we have a bunch of inputs coming in. So let's say we've got, again, a Twitter review, okay? So we have something coming in looking like, this is a very good company. And as before, we'll have some dictionary of all possible words in our corpus. Okay, so this might be from, let's say, 0 to 10,000. I'm just picking 10,000 because it's a fairly small set of possible words. And then each word would be represented somewhere in here. So this might be a 1, company might be 15, it might be 4, and so on. So this we could convert via the dictionary to a vector of numbers, which are the indices here. So this, let's say, might be the number 1. And then we might have is, I'm not sure what number that is, 37. A is the number 4. Very is somewhere in here, 127. Good, let's say that's 53. Company, and company is 15. We could feed this into a neural network. Part of the problem is, though, that any given review, let's say we're not using Twitter, we're using Yelp, where we don't know how big the reviews are. So some reviews might be 10 words big, some reviews might be 100 words big, some reviews might be 1,000 words big. And so the question is, how large are we going to make our input to our first layer? Right? We would be feeding in, let's say, some list of numbers, and the question is, how wide is it? Right? And that's going to determine then the size of our first matrix. Yeah. And so we need to come up with some maximum length. Maybe it's 10, maybe it's 100, maybe it's 1,000. Maybe we'll just take the first part of the review if it's too long, or the part of the first and part of the last if it's too long, or subsample or something like that. One way we can avoid this problem of having this variable length is to go ahead and convert this to what's called a bag of words. That is, we're going to just sort of take every word number from the review, and we're going to put it inside a bag, and we're going to shake up the bag, and then we're going to just look in and say, what are the words? So we're going to totally ignore the ordering of the words. That means man bites dog bites man, both show up the same thing. It's 3 words, bites and dog and man, and we don't know what the ordering is. So we would convert this then into a really long so this length is the length of the actual review. This length is going to be the length of the dictionary. And we are going to put a 0 if that word doesn't occur in the review, and a 1 if it does. So it's kind of like a multi-hot encoding. So we're going to have a 0 at the first entry, right? And then we're going to go ahead and put in a 1 because this is index 1. And then we'll have some more zeros for index 2 and 3. At index 4, we have an A, so we'll put a 1 in there. And then we have some more zeros, and then we have a 1 for the word 15. And then we have some more zeros, and we're going to have a word 37 in here, and that'll be a 1. And 53, and 127, and then a lot of words that are 0. So we'll have a 1 here and a 1 here. So this will be index 1, index 4, index 15, index 37, index 53, and index 127. So another way you can think of what we're doing is we're just taking a set. So we're taking the entire words in our input, and we are just creating a set out of them, an unordered set. One could actually keep a count. So if you've got a review which says good 5 times, then maybe you want to have a 5 at the entry for the word good, showing how many times it occurred. And that means probably if you have the or a, that's going to probably have fairly high counts. So this is the bag of word approach. This is the vector that you would then send in to the neural network. Just a simple occurrence map of whether this particular word has occurred or not. We lose all the ordering information. So this is bag of words. It's often something worth trying to begin with because it's a very simple model to use, right? It's easy to create this bag of words. And then the downside is this is a large matrix, right? Because this is going to be some sort of a 10,000 by whatever the size of the first layer is.